We're going to do just a quick intro for the new folks and then probably take a deeper dive on the topic of blueprints, maybe some rendering stuff. So here you go, Zach.
Hey folks. That's awesome. So again, Zach Parrish, I work for Epic Games. I'm a tech artist, basically to play with the tools all the time. So here's the deal, right? We got 40, maybe 45 minutes before they're probably gonna get the hook out at that point. So what I'm thinking is that there's actually, since you guys probably know what YouTube is, there are some YouTube videos out there that give kind of the base level intro, the same thing I did at GDC, and matter of fact, the same thing I did about an hour ago. So I'd like to just jump in and do some cool things in Blueprint, which is Unreal Engine 4's visual scripting system. How many programmers do I have in the room right now? I'm not sure how you guys are going to take what's about to happen, really. So Blueprint is visual scripting. How many of you as programmers audibly groan whenever you hear visual scripting? It's okay, a lot of you, yeah, exactly. They're like, I could have done that in one line of code, right? I always get that. Like, I'll make the coolest thing ever in Blueprint or Kismet if I'm using UE3, and like a programmer will always come by and they have the same thing. They're like, I could have done that in 2 lines of code. And that's okay, we embrace that. But the point of the matter is that in Unreal Engine 4, we realize that there are a lot of people out there who want to make games, and not all of them have CS degrees, and not all of them know how C++ works. So you might be like me, and the idea of compiled code scares the living hell out of you, and you have nightmares about it. So that's why we have Blueprint. And what I'd like to do is do some cool things in Blueprint, but I have an option for you guys. You guys need to be a little bit interactive. I have something that is fairly useful and involves interactivity on characters, and I have something that is kind of bizarre and fun. So, who wants somewhat useful? Who wants bizarre and fun? Okay, we'll go with bizarre and fun, and if we have time, we'll come back and revisit useful. So, let's see here. Let's start off. We're going to make our own game project. Currently, I'm in a project that already exists in UE4. Let's just do our own thing. And I'm going to readjust my very crazy workspace. Is that going to work? Oh, look at that. Extra cabling is awesome. So, file, let's do a whole new project of our very own. And if you haven't yet played, how many people have played with UE4 a little bit so far? Oh my god, that's huge, I love that. How many people are going to? I want everyone else's hand up. That's right. Okay, so in the project, when you create a new project, you get the project browser, and you're gonna see a variety of different templates that you can choose from if you want kind of a head start in a certain genre of gaming. So you'll see things like first person, you'll see side scrollers, third person. We've got more of these on the way. We're actually about to release at least one more, and we have some more that we're planning. So with each one of these genres though, you'll notice there are 2 versions. Like if you take a look at first person here, we have Blueprint first person, and we have Code first person. So if you're a C++ programmer and you have Visual Studio installed, it can be the free Express edition if you don't have Pro. You can use the Code version, and everything that you do, all the things that you need access to, are right there in C++ code for you to make edits to them. If you're not a coder, me, then you can make the Blueprint version where the exact same thing has been done with the exact same functionality, operates the same way, but it's been done visually in Blueprint, which is what we're going to look at. So let's call this My Awesome Project, because I'm super clever with my names. We'll hit Create. Now, there's a little checkbox there that says Include Starter Content. That's just going to give me some basic materials and some meshes to play around with if I want to do that a little bit later. So here we are. In my first-person template game, I can reach up, I can hit play. And, oh, I turned the sound off earlier. Let me fix that. Let me also try not to deafen people, because I might. Is that true? Pull it down just a little bit. So, first person template, pretty straightforward. You get a character, of course you get a little gun here, you get some projectiles, and even that is strangely satisfying somehow. So what I want to do is I want to create kind of a random bizarre effect. We're going to rain physics objects down from the sky. So this actually gets to cover some random spawning stuff. We're going to do some stuff with variable materials so that you can get a randomization effect. And I thought a lot about what we should actually use to rain down from the sky. And in one of the other projects that I have access to, well, maybe I should just show you. Let's do it that way. first off, let me make sure I know exactly where we're going to be here in our chain. We're in the documents project. I'm totally cool with that. So I'm going to jump back a project, back to what we were looking at just a second ago. And buried in here is a very special asset. So you actually get to see how to migrate assets from one project to the next. Let's take the content browser, and I'll just bring it front and center for just a moment. And let's see. Let's do a kind of a telling search term here. Let's search for cows. There he is. So I've got this little static mesh cow. Isn't he awesome, by the way?
Gosh darn it.
Let's rain these down from the sky. That'll make me really happy. I need that kind of satisfaction. So what I'm going to do is here in the content browser, I'm just going to right click on that and choose migrate. And it's going to say, here's all the things that that cow depends on. Here's all its textures, all its materials. All the things that make it up are going to have to migrate along with it. And that's good. So we'll click OK. Now it's going to say, where do you want to send that to? So let's, I don't want to do that. Let's find my documents. There's my Unreal projects. There's my awesome project. And there's its content folder. So we'll select that, click OK. And we get a little message. Content migration was successful. Awesome. So we'll go back to our recent projects and jump back to our project. Yep, it's fine. By the way, for all my UDK users, gone are the days where you have to do multiple installs of UDK, right? So you just have one install, you just have multiple projects. That alone made me so happy. So now back here in our project, we can jump into the content browser, and now let's search for cow, and our cow is here. Now let's do a couple of things with this cow. First off, I want to take a look at its material. So currently, here's its material network. It's really not super complicated. We have three colors. We have the base color, which is kind of if this cow is white. If we actually want to see this on the mesh, by the way, all we need to do is select the static mesh and click the set mesh button here in the preview, and now we can see our little cow right here in the material editor. So we have three colors. We have white, pink, and gray. You can kind of see how those are placed. Let's mess with that just a little bit. So I'm going to take the spot color, and I'm going to make a slight change to it. Now, by the way, you'll notice each one of these nodes has a green bar at the top. That means these are parameters. That means I can talk to them later using Blueprint or code. It's basically an aspect of the material that is ready to be edited. We're going to take the base color, and we are going to multiply it by the spot color. And then we're going to make that result feed into the spot color. It's not going to be a really significant change in terms of our cow, but what it means is, if we take the base color and change it, like let's say for some random example, we want a stylish pink cow, those spots are going to pick up just a little bit of that color. So I like that idea. I also like the idea of our cow going back to white, at least for a little while longer. Okay, so we're done here. Let's go ahead and save our changes. And I'm going to try to remember that the parameter is base space color, because knowing that name will be super helpful. So now we have a couple of different effects. There's a lot of different ways you can handle any particular problem in code, in Blueprint, in life, whatever. So I'm going to create a Blueprint object that we can just rain down from the sky, and we'll populate that with a cow. So let's go into my Blueprints folder, and I'm going to just pick an empty space. We'll right click and create a new blueprint. This is going to bring up the parent class window. Every Blueprint asset you create needs to have a parent class. What is this going to instantiate from? In this case, we're going to choose actor. Actor is pretty high level. It just means anything that could exist in some way in our game. We have options, though. We could make a character blueprint or a player controller or a game mode. We don't need any of those at the moment. We'll just choose actor. We need to give this a name, so we'll call this dynamic cow, because he's going to be a physics object by the time we're done. We'll open this up, and now we need to start assembling our Blueprint object. Now, a blueprint can be, it's comprised of several different things, or it can be. It has components that will make it up. In this case, it'll be like a static mesh, but it could have other things too. We could add things like a light component to it, or a sound component if we wanted our cow to moo every so often. So he has some default settings, he has the components that will make him up, and then we have the graph which will define his behavior. Let's start with components. Obviously, we need our mesh in here. So I'll just make the most of my user interface. Let's bring up our cow over here. Here's a static mesh. I'm just going to drag and drop that right into my components list. So suddenly, my blueprint has a static mesh cow in it. Perfect. And we're going to change some of the settings of that static mesh cow. We're just going to scroll down, and one of the properties available in here is simulate physics. We'll just check that and make sure that's on. Really, I think that's about as far as we need to go right off the bat. If there's more that I need to do, I can always jump in and do that a little bit later. So now, next thing, we need to set up some behavior so that when this guy is born, he gets a random color. So here we are in the graph for this blueprint object. And we're going to right-click and create a new event. Very much the way Kismet was in Unreal Engine 3, you can create events and actions. The only catch is you now have to think linearly, which I'll explain here in just a moment. So let's see here. Let's do event for begin play, which is literally the moment this actor comes into being in our game, then we want something to happen. Well, we want to talk to its material, but we don't even know what that material is going to be right now. We have no direct or easy way to access it. So what we're going to do is jump over to our other graph. We actually have two graphs for this object. We have the construction script, and we have the event graph. Now the construction script actually fires in the editor. It's kind of like before this thing ever comes into being. So let's see here. We're going to take our cow. So currently we have the static meshes. Check it out. Over here in components, you can see here's a list of all our components, and we have our one static mesh. Let me rename this just for clarity. We will call this our cow mesh. And now back here in the graph, I can take that cow mesh, drag it right into the graph like so, and now we can start doing things to it. So let's get its material. So now we have direct access to the material that was applied to it. The next thing I'm going to do is create a dynamic version of that material. That material that we created is going to be compiled, and then it's going to remain static throughout gameplay. If I want a dynamic one that can actually change during gameplay, I need to make a dynamic instance that exists within this object. So that's what we're doing now. Now, I need to tell my construction script to make that happen, so I'll connect my execution wire. Now, earlier, I grabbed my cow mesh, we got its material, and we're going to take that material and make it dynamic. So really just plugging some things together. This is the very heart of visual scripting. Now that we have a dynamic version, there's two things I want to do. I want to store it in a variable so we can talk to it again later on. And I want to apply it back to our mesh. So let's start with the storing bit. Here we have the node that creates that dynamic version. I'm just going to right-click on its return value and promote that to a variable. We'll call that dynamic material. Done. That was easy. Now we just need to apply this back to the mesh itself. So let's take a wire. Remember our little cow mesh over here? We can drag a blank wire out here and say set material. Now it's going to ask for a few things. It will say what material element, 0 is fine because something only has one material. What do we want to actually apply? This dynamic version that we created a moment ago. Done. Everybody kind of see how that worked? A lot of nods. People are still awake. That makes me happy. Who isn't awake right now? Gotcha. Totally hear you. Got the hood up and everything. You look comfy. All right, so we've got our event begin play. So now we've got a dynamic version of this material. We can grab this, and now we can use this to start talking to the parameters in that material. So let's say we set vector parameter, because that color is just a vector. We need to know the name of that parameter. It was base color. Now, what value do we want to give? I mean, we can set this to anything we want, but we'd like something that's a little bit random. Now, to make that happen, we have to know a couple of things. First off, we have to know that a linear color value is just a vector, but it's a vector with 4 elements. We have red, green, blue, and alpha. Oh my god, I have audience participation. This is awesome. As long as you guys aren't throwing rice, I'm okay. Who brought rice to your toast or a newspaper? If you're getting these references, thank you so much. All right, so what I'm going to do is I'm going to work backwards in Blueprint. This is actually one of my favorite ways to work. I know that I need something that will end up being a linear color, so let's make one. Oh, there we go. We have a node that is going to make a linear color out of 4 float values. How are we going to handle that? Well, let's take our first float value. Again, we'll work backwards, and let's just type the word random, and we get some options. So we're going to do a random float within a range. And the way our colors work in Unreal, for red, green, and blue, it's just going to be a value between 0 and 1. So we'll set min to 0, max to 1. We'll take this node, we'll duplicate it, and we'll plug each one of these into RGB and A. And by the way, if any of the programmers in the room were kind of like, well, why didn't you just get a random unit vector or something like that? You can totally do that. It just gives more vibrant colors if you do it this way. All right, so I think that's going to work, but there's a catch right now. We don't have anything actually spawning this guy just yet. So let's put this guy away. We're done with the dynamic cow for a moment, and let's build our spawning system. So I'm going to make an entirely new blueprint now. Let's just right-click, and we'll make a new blueprint again from the parent class of actor, and we're going to call this cow spawner because sounds like a useful name. We'll open this up, and again, we just get sort of a blank slate where we can start adding components, adding behavior, and so on and so forth. So the way I want to set this up is I would like there to be a three-dimensional volume, like a box, and we will spawn our cows from random points within that box, right? So it'll be kind of like a volume emitter. So let's start with a box. Probably the easiest way to do this. So there we go. We have a box. Done. Now in the editor, it's going to be a little tricky because this is just a wireframe box, right? Clicking on selecting anything that is just a wireframe can be a little bit of a pain. So let's add a billboard, which, by the way, still is the old school dragon icon from years and years ago in Unreal. It's one of those little things that makes me kind of happy. So let's compile that. Right now it doesn't do anything. And let's just add it into our level. I can move it up here into the air. We can scale it, change its size. It's pretty much set to go. Now we just need to set up some behavior for it. So let's go into its graph. And we want, whatever this is going to do, we want it to do this as soon as we begin playing. So we will right click, and again we'll say begin play. So on begin play, we want to do something. And in this case, we want to spawn that blueprint that we just made for the dynamic cow. So we'll just drag a wire off of this node, and let's just type out spawn. And we get spawn actor from class. Perfect. We need to choose that actor, so we're going to click on the little drop down here and use our search bar. Let's type out dynamic cow. There it is. Cool. So we're going to be spawning these, and that's good. Now, there's a few catches here. We need to know where we're going to spawn it from. So we need to make a random selection point within the volume of our box. So what I'm going to do for starters is grab that box component, which is currently in my, my blueprint list there. We're going to get that. And let's say I don't really know what I want. So let's just drag a wire off that and start trying to make things up. So here I can get the extents of the box. So let's say if I type extent, or if I could spell extent, that would probably help. So we have a choice. We can get the scaled extent of the box or the unscaled extent. I want this to be really accessible to a user. I want them to just be able to grab this volume, drop it into a level, scale it up to whatever they want, and it just works. So we'll grab the scaled extents of the box, like so, and that just gives us a vector for the x dimension, the y dimension, and the z dimension. So we can use that kind of as a base, but we're going to need to break it up. So let's break that vector into its x, y, and z. Now, we need a random range within each one of those axes. So let's start there next. We'll just right click and say random float within a range. And of course, once again, that gives us a min and a max. Now, our extents of the box, those are just going to run positively. That's just how it works. So what we're going to do to make this work is we will take, say for the x-axis, we'll take x and make that the max. For the min, we'll take x, we will hit the multiply sign, so we'll multiply a float by a float, and we'll say -1. So we just made a negative version of that x-axis value, and we'll plug that into minimum. So we're going between the negative extent and the positive extent. We just need to do this 3 more times. So we can grab these 2 nodes, Control-C, Control-V, Control-V. Now let's just plug in some stuff in. Take y, plug it into max. Take y, plug it into our multiply node. Same thing for z. So I now have 3 random values that represent random locations along each one of these axes. Now I just need to make them back into a vector, because now there's still 3 disparate numbers at the moment. So we can take any one of them, drag a wire out, and say, make a vector, and then just plug each number in. Now, that gets us most of the way there. There's a catch. All we're getting right now is the extents of this box, but we don't have an origin point. We don't yet know where to start the calculation from. That's pretty easy to get. So we're just going to take, you can just right-click here in space, actually, and say get location. And there's one of the things that pops up is get actor location. That is where this guy is placed. That's where we can begin all of our location calculations. Now let's just add the 2 together. So we'll drag a Y. Isn't this math stuff exciting, by the way? Who's bored yet? Oh, good. I want to love math and I want to be good at it. I can't do either of those things, but I can fudge my way through for this kind of stuff. So there we go. We're now adding these together. We have our random location. We have only one last thing to keep in mind, and this is sort of an unrealism, or you might be familiar with this depending on how much game work you've actually done. What we need is a transform. Transform is not just location, that's location, rotation, and scale all together. So we can take our new location that we've created, and let's say make transform. And that's also asking for some inputs for rotation and scale. We could leave those just as they are, and everything would work. But let's have a little bit of fun with this. So for rotation, we can work backwards, and we can say random rotator. So now each one of our cows will have a random rotation. We'll let it roll them as well, so we'll just check that on. And now for scale, let's work backwards again. So we'll say make a vector, and just like we did earlier, let's do a random within range. So we need to decide what the largest and smallest our cow can possibly be. Let's just guess. We'll say small will be about 0.5, large will be about 1.8. We can always adjust it later. And then we're going to take that same value and plug it into X, Y, and Z. That will make this scale uniformly. I think we're pretty much done. The only catch is, and I realized this a little bit too late, we're doing this spawn only when we begin play. I think what that's going to mean is we're only going to get 1 cow. Well, that's exactly what that means, but let's give it a try anyway. Let's just play, and oh, we get our 1 cow. But he does have a random color, because he wasn't yellow before. We're going to shoot him. Which is strangely satisfying. But let's change that up. Let's modify the behavior slightly. So let's get rid of begin play. And we're still doing pretty good on time. Let's do on tick, which means every single time the game cycles, it's going to spawn another cow. Now that's a bit extreme, right? That means we're going to get a whole lot more cows than we probably need. So as a safety factor, let's put a quick delay in here. And we'll 0.2 is fine for starters, but let's say maybe 0.05. So it's not going to be quite on every tick, but it'll be a hell of a lot of ticks. Let's jump in here, and I can play or I can simulate. Let's just simulate too again. Oh, that makes me so happy. I'm sorry, I'm supposed to be giving a demo, but I really...
I could have written that in 2 lines ago. Okay, I'll do that. You guys can't do that in 2 lines ago?
Anyway. Moving on.
Oh, I get it.
Okay. Too much coffee, that's what that was. All right, so I guess the next problem that we have is that these cows live forever, which while that is kind of joyful and makes me pretty happy, the catch to that is that, of course, over time, you're going to have so many cows that your computer is going to start to slug a little bit. So let's make a self-destruct system. You guys want to blow up some cows?
Yeah, sure.
Okay, so here's how we're going to do this. First off, we're going to make a new blueprint. And if you are taking notes, the only thing I'd really like you to take from this is kind of the mentality I'm using. I'm going to make a new blueprint that I'm going to call Explosion. You might be wondering, why on earth would you do that? Why would you make an explosion blueprint? Well, that's because an explosion, when you think about it, is several different things. It's never just the visual effect. An explosion is going to have sound, an explosion can have force, we can make it have force because these are all physics objects, and we have a particle effect as well. Anytime you need one thing to be made up of multiple bits and pieces, multiple components, you should be thinking in your head, could this be a blueprint? So let's do it that way. So let's start off with the particle system. We know we're going to need one. No, actually, I'm going to change my mind. Let's start off with our force. Let's do a radial force out of this. So here in my add components list, there's some stuff that I can add by default. So if we take a look, there's a radial force. Now let's open this up. I know you guys can't really see the screen very well from here, so you have to take my word that everything you see here is awesome. The radius of this force, let's kick that up to about 500, and we can always adjust that later if we need to make it bigger or smaller. Impulse and force strength are what really give us our outward push, right? So let's see here. Let's set that to something really low and sensible, like 1,000,000. We'll set that for both of them. You know, just trying to keep things nice and subdued and sensible at all times. Then let's see here. We can go ahead and add our particle effect. That'll be fine. So let's go over to the content browser, and here in the games folder. So if I just search for explosion, we get our little P. There's a P explosion here, or I could just, you know what? I'm going to do this a different way, just kind of for academic purposes. We'll spawn that actually as part of the behavior. So we have our force. We could add an audio component. That'd be great. So let's do audio, and we need to just tell this what sound. There actually is an explosion cue. So that comes in with that starter content. If you guys remember when I created my project, we had a little checkbox for starter content. The explosion stuff is already in there for you to play with. We won't worry about multiplying the volume, though. I gotta admit that is pretty tempting. So let's now come over to our graph, and we will say on begin play, the moment this explosion is born, what do we want to do? First off, we want to spawn an emitter at location. What location do we want to give? Well, let's say the location of this actor. So we'll say get actor location. So wherever this explosion is, we're going to spawn a particle effect. What particle effect will we add, you ask? Well, the P explosion effect. It was there, all set to go. That was super easy. This also allows this to be automatically destroyed as soon as it's done. You can see the auto destroy checkbox if you can read that from here. The next thing we want to do is, right after we're born, we want to delay very briefly, and then let's turn off that gigantic force that we have. Because if not, it's just going to keep pushing things out. An explosion is just like one quick, and then it's done, right? So we'll do a very brief delay. Let's say something like 0.1 seconds. And then we will destroy a component. And since it's gonna ask us what do you want to destroy, we can just take our radial force component that we've added, get a reference to it, drag a wire off, and then just type destroy. Boom, that's gone. Awesome. Now, let's see, our sound effect, and now I'm cheating for time, right? So I know my sound effect is about 4 seconds long. So we will delay further by about 4 seconds. We'll say like 3.9 because we've already delayed by 0.1. And as soon as that's done, we are going to destroy this actor, meaning the explosion blueprint is going to kill itself and be gone. So it's a pretty easy network to grasp. The moment we're born, we spawn a particle system, we wait a second, we turn off our force, we wait a couple more seconds, and then we kill ourselves. Perfect, I love it. All right, so let's go ahead and save this and compile. Now, meanwhile, back over here in our CAP, we're going to create a new custom event, which we will call Kill This Cow. When Kill This Cow is called, all we really want it to do is to spawn an actor from class. Now, can we tell me what we're going to spawn? Explosion. The explosion, exactly, perfect. So we'll spawn the explosion. And then we will simply destroy this actor. So we'll kill the cow, spawn the explosion. We had to do it in that order, by the way, because if we kill the actor first, we never get an opportunity to spawn the explosion. Now we do need supply transform here, so I'm just going to work backwards and we're going to cheat this time. We're going to say get actor transform. So wherever this cow happens to be, that's where we're going to spawn the explosion, and everything should be good to go. Now, we have just a little bit of work left to do, and plenty of time in which to do it. I want this to be, well, I guess there's a couple different ways we can do it. Let's do it the simple way first, just for sake of ease. Notice here, on event begin play, we choose our random color and everything. Let's give a delay. Let's say after, how long before we start blowing these up? 2 seconds? 3 seconds? Let's let them pile up for a bit, so let's say 5 seconds. So say after a 5-second delay, ooh, actually, you know what? Let's do a random delay. I like that better. Random is a lot more fun. You can take that in a lot of ways. So let's take the duration, and we're actually going to feed that a random value between, oh, I don't know, let's say 3 seconds and 5 seconds. That'll work. And as soon as that's done, we will simply call kill this cow. That should be it. Hopefully this works, unless I've done something horrible. Make sure I saved everything, just in case I actually do blow something up. Ha ha, it's happened. And let's see, let's just simulate it. So, they're blowing up, but it might be a little forceful. It's possible that that's a little extreme. Yeah, maybe we back off the force just a little bit. But hey, everything's working, right? We got our force, we got our particle effect, we got our sound. The particle effect actually emits its own light, so we don't have to worry about that at all. That makes me really happy. Let's take that radial force component and maybe pull that down slightly to, oh, I don't know, let's say 500,000. Let's try 1/4.
Is that like actual measurements, like newtons, or is it?
I believe the answer is it's the amount of force applied to the actual mass of the object, because we define all our sizes in centimeters. Mass becomes grams and kilograms, so I think it's newtons, but I was never very good at actual physics. Usually I just punch in numbers until I get the kind of explosion that I want. That's the artist approach, right? And that's where all of like the CS degrees are kind of like, don't worry, they'll come behind me and clean everything up, right? That's what they do. Okay, so let's see. Let's just test this out now with a slightly softer explosion. Oh god. Oh, I love it. Get away! Okay, so I've still got, well, I'm down to the wire in terms of time, but I want to do something a little bit fancy. So what we're going to do is I'm going to build a self-destruct button. So we blow the cows up when we feel like it. Here's the way we're going to do this. As each cow is created, notice we have a return value. We see that cow, right? So let's take that and let's promote it to a variable, which we will call cows. We'll keep this super simple. I'm going to disconnect it. I'm actually going to remove it from the graph real quick. I just want it to exist so I can turn that into an array. Go ahead and compile, make sure there's no errors. So I now have an array of all of the cows. So let's get that. For each cow that is built, I want to add an element to this array. So there's a node for that. So now we're doing some programming stuff. We're working with arrays. What are we going to add? Whatever came out of the actual spawn. Each time we build something, we're storing it into this array. Very straightforward. Okay, now what are we going to do? Well, let's create an input. And there's a few different ways to do this. I'm going to show you the right way, though this is going to be so fast that if you're taking notes, you'll get it. I'm going to go into my project settings, and under inputs, I have some action mappings. Let's go ahead and add one. We will call this action mapping cow self-destruct. And we will expand it, and we will slave this to, let's say, the E key. Boom, easy, done. We'll save that as a default. Great. Close this off. Okay, now here inside of our cow spawner, we're going to do something a little bit Not something I would recommend. Usually I'm a lot more elegant with how I handle inputs, but for sake of speed, we have auto receive input. We're gonna set that to player 0. That means this guy is always listening out for inputs from player 0. Now that we have that in place, we can just right click here in the graph, and let's see, we have cow self-destruct. I have an event for it now. So whenever I hit E, this event is going to fire. And what do we want to do? Well, we have, actually, I'm sorry, I'm putting this in the explosion. Let's not put that in the explosion. Let's get out of that. We don't need that anymore. Let's go over to cow spawn. Thank you. Did I? You know what I did too, didn't I? But we don't want him to listen to input. That's good. Cow spawner we do. Awesome. Just make sure I'm in the right object at the right time. So, self-destruct for the cows. Boom. What are we going to do? We're going to run a loop for each loop using this array. All right. Let's just do it this way. So, for each, boom. Fantastic. So as soon as we press this, we're going to fire off a for each loop using our array of cows. And what do we want to actually have happen? Well, for each one of those, for each element that comes out, which essentially is each cow, we want to call the kill this cow function. And notice the system is aware of that. Since this is actually using the cow class as a data type, it knows the kill this cow function exists there. So we can call that. And unless I'm terribly mistaken, this should already work. We just need to make sure we take our cows and kill that part of it that makes them blow up on their own. So I'm just going to disconnect that by alt-clicking on the wire and make that go away. So if this all worked, and I didn't do anything too horrible, we should be able to play the game, let the cows build up for a while, shoot a couple of them because we're bored, and then hit the E key, and they all blow up. Now, last thing, because we literally are down to the wire, but it's going to make this so much more satisfying. Let's take the dynamic cow, and when we kill that, let's do this. Let's do a delay as soon as we kill it.
You got 15 more minutes.
Do it really? I thought it had to be done at 12.
It's 11:15, 12:15.
Okay, well, you know, we'll make it work. So we'll do a delay, and then let's do a random range. Random, you know, I can't spell. And let's say as soon as we kill this, you're gonna, or as soon as we fire this event, you're gonna wait for anywhere from 0.2 seconds to about 1.5 seconds, and then you're actually gonna blow up the cow. That'll work. So let's close all of this out actually. I'm gonna do a file save all so I don't lose anything, because that's happened before too, and it's always depressing. Let's take our volume, we'll make it a little bigger, let's hit play. Oh my god, get out of the way. All right. Okay, sorry. Let's hit E. So it's only blowing up the ones that existed at the time. There we go. And you can see how the delay changes things. So you guys got what you asked for. We had between useful and fun and bizarre. I hope this was fun and bizarre enough for you. Do you guys want Q&A, or do you want me to try to, hang on, thanks. Or do you want me to try to show you some useful stuff too? Useful stuff, okay, we can do useful stuff. So, what I want to talk about, I guess, for our useful segment, which I will kind of, sort of, burn through fairly quickly, is making things interactable in your game, which can mean a lot of different things, right? When you're playing a game, you want to be able to walk up to, we're already using the E key to blow up cows. I'll probably change that in a minute, because usually when you hit the E key in a game, that's going to do a variety of different things, right? In some cases, it might pick up an object. In other cases, it's going to open a door. In some cases, it's going to turn on a light. I want to show how to set up that type of relationship quickly and simply using this first-person template. But first, we need some things that we can actually work with, some things we can turn on and off. So let's see, we've got this ceiling light that already exists here. We've also got this little wall sconce. Let's grab the wall sconce. I think this might be a kind of an easier way to work with this. This is a blueprint that already exists as a part of the starter content. So I'm going to grab it, drag it onto the wall, we'll frame up on it, and let's hit G so we can kind of see it a little better. It needs to be aligned to the wall surface. So I'm going to rotate it a little bit. There we go. And you can see it's shining a little bit of light on the wall. We could take the whole thing and scale it a little bit, and that might kind of help make it a little more visible. Oh, also, when I hit play, let me make sure that I'm playing from the location of the camera and not from the player start. That way we don't accidentally jump around to a location we don't really want to be at. So what I'd like to have happen here is be able to walk up to this light and just turn it on and off using the E key. Right now when I hit E, all the cows blow up, so let's fix that first. I'm going to go over to my project settings once again. You remember on my inputs, we took those action mappings and we had cow self-destruct, currently slave to E. Let's change that over to R. Push that one key over. And then we're going to add a new action mapping, which I will call use. We'll expand that. Let's actually set this one to the E key. That's a little more conventional, something you might have actually seen in 1, 2, or 5,000 different games you might have played. Now here's the deal. Our cow spawner, we set up earlier, we cheated. We told it should always be listening out for inputs from the player, but generally that's not how you want to handle things. You want to be a lot more, I guess, elegant with how you handle inputs and how you pass them off between different players. So let's start there. Let's set up our little wall sconce here so that it can dynamically hand off control to the player and take it away. And a common way to handle that is via proximity. Only when the player is close to something should they be able to actually use it. When they step away from it, they shouldn't be able to use it anymore. That's pretty easy to set up in Blueprint. It's, in fact, in a lot of ways, it's very similar to how you used to do things in Kismet, if you've ever played with that. You had things like trigger volumes and whatnot. We're going to do something really similar. Let's go over to our components list, and here we can see the wall sconce, and we can see the light component that makes it up. To this list of components, we're going to add a box component. Now we're going to resize this a little bit so we can move it around freely, we can scale it. We have all the same types of controls that we had in the viewport. We'll make this a little bit wider. Actually, it doesn't need to be super wide. Let me pull that in just a little. And we'll kick up its thickness. And then I'm going to try to make it kind of flush with the back of the light fixture. It does not have to be perfect. This doesn't necessarily need to be an exact science. But if you get a lot of these overlapping, you could run into problems. So you want to keep this fairly trimmed down to just the object you want to interact with. Let's call this, let's actually give this a name, so we'll rename it Trigger. Perfect. Now, back over here in our graph, we're not really worried about the construction script. In this case, just to show off, what the construction script is doing is allowing us to set some public variables for our light. So you see over here, I have the brightness that I can adjust. You get real-time feedback. We can take the light color and make that really anything we want. And that's because each time I make a property change, the construction script is firing. Now, in terms of gameplay, the construction script will only fire the moment this is spawned when you play, and then it will never fire again. So it's a way for you to have some in-editor behavior, as well as using the event graph for your in-game behavior. So in terms of that, let's take our trigger, which I just added a moment ago. I'll drag that in. Actually, let's not drag that in, I'm sorry. We're just going to select it over here in the My Blueprint list. Right-click, and at the very top, you see we can add events for it. And one of these events is called onComponentBeginOverlap, which is a little bit of a mouthful, but what that means is when we have entered the space of this volume, when it is overlapping with us, we want to do something. On that note, that reminds me, over in our components, we want to make sure that that trigger has some specific collision properties. An easy way to do that is just change its presets. We'll tell it to behave like a trigger. So that happens to be one of the names of the presets. If you want to know what that does, if you're the kind of person who says, I hate presets because I never know what's going on under the hood, all it's doing is changing a series of checkboxes about how you're going to collide with objects. Are you going to block stuff? Are you going to register overlaps with stuff? What types of objects do you want to collide with and not collide with, and so on. We're just going to use the trigger preset for the sake of speed. And then on our component begin overlap, we want something to happen. What we're going to do is we are going to enable input.